Hello everyone, I welcome you all to this class. This is mathematics class, and today we have this interesting topic to consider: derivative of inverse hyperbolic functions. Now we have in our previous class we studied the derivative of hyperbolic functions, and I wrote down some examples of hyperbolic functions, and we saw their respective derivatives, and we consider some examples. But in this class, we want to see how we can differentiate inverse hyperbolic functions. So, and I'm going to show you that using examples. So we have this first example. We have they say if y is equals to hyperbolic sine inverse of x over a, prove that the derivative of y with respect to x is equal to 1 over square root of a squared plus x squared. Then the second part is if y is equal to hyperbolic sine inverse of tan x, find the y dx. So let's look at the solution of this question. So for the first one, we want to prove that, so I'll write proof, right? And we are given y is equals to hyperbolic sine inverse of x over a. Now, if you have something like this, sine, for instance, I'm giving an instance. If you have sine theta equals 1 over 2. So this simply implies that theta will be equal to sine inverse of 1 over 2. Right? This is just an instance. We want to use similar illustration here. Now, theta equals sine inverse of 1 over 2. Y equals hyperbolic sine inverse of x over a. Now, we have that sine theta will be equal to this quantity inside here. So we are expecting hyperbolic sine of y to be this quantity here. So this implies that what? Hyperbolic sine of y is this quantity. Hyperbolic sine of y will be equal to x over a. If you want to write this hyperbolic sine, don't forget to put your h after spelling sine. So if you do not put your h, it means what you wrote down is normal trigonometric sine function. So for the hyperbolic sine function, we'll put this h. So what does it imply? We are going to make x the subject of the formula. How do we make x the subject of the formula? You can simply multiply both sides by this a here, the denominator here, or you cross multiply, right? Let's multiply both sides by a. Multiply here by a, multiply here by a. If you multiply here by a and a will get cancelled, remaining your x. Multiply here by a, you have a hyperbolic sine of y, right? Then it means that a is now the what? Sorry, it means that x now is the dependent variable, while y is the independent variable, because x now is made the subject of the formula. So x is the dependent, y is independent. So if I want to differentiate this, so I'll be differentiating this x with respect to y. So I will now say the y, I will now say the x, I will now say the x, the y will be equal to, if you differentiate hyperbolic sine, we have seen that in our previous video. Differentiate hyperbolic sine, you get a positive hyperbolic cosine. So I have positive hyperbolic cosine of y. So, but we are looking for, in this proof, we are looking for dy dx, not dx dy. So we can take the inverse of this, or reciprocal of this expression. So we are going to take the reciprocal of both sides. Reciprocal is just 1 over, right? So taking reciprocal of both sides means 1 over this fraction, 1 over this quantity. So what I mean is, for the left hand side, what is there is the dx dy. So taking reciprocal of it is do 1 over this without quantity, x dy. And whenever you do 1 over a fraction, the denominator will become the numerator, while the numerator will become the denominator. So the fraction reverses. So whenever you do 1 over a fraction, so this implies, so the y will come up, the x will come down. So we now have the y dx will be equals to, so this equation you are going to do 1 over this quantity here, also 1 over a hyperbolic cosine of y. So that's what we have there. So now we have gotten our dy dx, but it's in terms of hyperbolic cosine, not in terms of x and a. So not in terms of a and x as we have it in our proof here. So let's write this hyperbolic cosine in terms of x and a, so that we'll get what we want. So you come to that very first step in your proof. So after writing what you have, what's the very first step? This was the very first step. You come to it. So you are going to write this quantity here in terms of this sign, hyperbolic sign, so that you can replace hyperbolic sign with x over a, right? So I'll write this quantity in terms of this hyperbolic sign. But we are going to use the identity. In our previous video, I told you that hyperbolic cosine of cosine squared x minus hyperbolic sine squared x equals 1. That's what I gave you in our previous video. So if I want to make this, I want to get this in terms of sign, so that I can replace sign with x over a. So I will make this hyperbolic cosine is always the formula. And we now have hyperbolic cosine squared x will be equal to, if you move negative hyperbolic sine squared to the right, to have 1 plus. So we have a hyperbolic cosine squared x equals 1 plus hyperbolic sine squared x. So, and we are looking for hyperbolic cosine of x, right? So what do you do? To remove this square, you take what? Square root, right? Take square root here. Square root to cancel this square. You have hyperbolic cosine of x equals to, take square root here. Square root of 1 plus hyperbolic sine squared x. So that's what you have. So I can rewrite this hyperbolic cosine y in terms of sine like this. So this quantity will be equal to 1 over a square root of 1 plus hyperbolic sine squared y. Hyperbolic sine squared y. So that's what that quantity will give us, right? So let's proceed. So that will be equal to 1 over a into square root of 1 plus. Now, what is a hyperbolic sine? Hyperbolic sine y is we got it here to be x over a here, right? So I will replace it. But we are having hyperbolic sine squared y. So you are going to do x over a squared, because hyperbolic sine y is x over a. Then hyperbolic sine squared y will be x over a all squared, which is same as x squared over what? A squared, right? So we have x, it will be x over a all squared, right? X over a all squared. And if you pass square to each of them, you will now have x squared over a squared. So this will be equal to 1 over a into square root of, we now simplify this quantity inside. You know 1 is same as 1 over 1, right? So that your LCM here will be a squared. So you now have your LCM is a squared, right? 1 divide a squared is a squared, multiply 1, you have a squared, plus a squared divide a squared, have 1, multiply x squared. So 1 multiply x squared is x squared, right? But this square root is for this fraction, isn't it? So I'm going to take the square root of the numerator over the square root of the denominator. This will be 1 over a into square root of, I do square root of the numerator, that's square root of a squared plus x squared. Then what is square root of denominator? What is square root of a squared? If you do square root of a squared, the square on a will cancel the square root. So if I do this, if I do square root of this denominator, this square will cancel the square root. I'll have my a. Right? So what will happen? A cancels a. So I will now have 1 over square root of a squared plus x squared. So that's what we will have. And that completes that proof. So for the second part, they say if y is equal to hyperbolic sine inverse of tan x, find the y dx. So we are given y is equal to hyperbolic sine inverse of tan x. So watch closely. This tan x is the normal trigonometric tan function, not hyperbolic tan, because there is no h there. So this one is given to us. We want to find the y dx, but we are going to use chain rule to do this. You have this is we have quantity inside here to differentiate. So we are going to use chain rule. We differentiate the inside, we differentiate the outside. What is inside is what? Tan x. So we are going to say let u be equal to tan x. So I will call the quantity inside u. So what does it imply? If u is equal to tan x, this implies what? This implies that y will be equal to what? Because I call this quantity my u. If I replace this tan x with u, my y will be equal to hyperbolic sine inverse of u. Right? So this is the one so we are going to differentiate this inside. That's this one. We are now going to differentiate this outside. That's this one. Right? So according to chain rule. So differentiate the inside, differentiate the outside, then multiply. So let's differentiate the inside first. Du dx will be, if you differentiate tan, what will you get? Sec squared. So this will be positive sec squared x. That's what you get. That's what you get. Then this one now, we'll differentiate this quantity. We differentiate this quantity with respect to what? U, right? Because we're having y is equal to hyperbolic sine inverse of what? U, isn't it? So we are differentiating this quantity with respect to u. Y is the dependent variable, yu is the independent. So we'll do the y du will be equal to what? So we'll use our previous result. What is given to us is that if you have that y is equal to hyperbolic sine inverse of x over a, then the derivative of y with respect to x is 1 over square root of a squared plus x squared. So that's what we have. So now we are having y is equal to hyperbolic sine inverse of u. So our x in this case is what? U. So x, this x here is now our u. And this a here is what is the denominator. What is the denominator of u? U is same as u over 1. So if you compare this quantity inside here and this quantity inside here, you notice that x is your u. This a at denominator is your what? Is 1. Because u is same as u over 1. So you come here and replace it. that's this result we got here. Replace a with 1 because our a here is 1. Replace x with u because our x here is this u here, right? So you do that. So this 1 over once we have square root of 1 squared is 1 plus we'll replace x with u squared. So that's the answer to that. So by chain rule we are going to have that the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. So that's what we have by chain rule, right? So this formula is just what I told you earlier. The derivative of the inside multiply the derivative of the outside. So what is the derivative of the outside? That's this one, the derivative of hyperbolic sine inverse of u. And we got it to be 1 over square root of 1 plus u squared. So we have 1 over square root of 1 plus u squared. So that's this derivative of y with respect to u. That's what we got. And remember, we used our previous result to get that, right? So multiplying, what is the derivative of u with respect to x? So we got that to be sec squared x. This sec is the normal trigonometric sec, not hyperbolic, because there is no h here. So sec squared x. So if you simplify, sec squared x will multiply this one at the numerator. We have sec squared x divided by square root of 1 plus, what is u? U is tan x, right? 1 plus tan, but we are having u squared and u is tan x, which means if u is tan x and you have u squared, so which means we will be having tan squared x. So we have tan squared x. So but you know from trigonometry, I want to simplify this further. You know from trigonometry that 1 plus tan squared theta is equals to sec squared theta. This quantity is the same thing as this. So this 1 plus tan squared x in this square root, I can replace it with what? Sec squared x. So this will be sec squared x, the one we have at the numerator, square root of, and this 1 plus tan squared x is same thing as sec squared x. So what will happen if you take square root of square? Square root of square will cancel the square root, right? So let's write what we have at the numerator. Sec squared x divided by square root of sec squared. Square root to cancel the squared. Square root to cancel the square, remaining sec plus x. So sec x divides sec squared x. You will now get what? Sec x. It's just like 2 divide 2 squared, which is 2. 3 divide 3 squared, which is 3. That's what we did here. Sec x divides sec squared x. You get sec x. So that's the derivative of that. So we are done with this question. Thank you so much for being part of this class. I'm expecting you in our next class.